Uh, is my voice clear?
Okay, it has to be switched on.
So, hi everyone. My name is Sharath, and today I'll be talking about how Flipkart is using Aerospike with Kubernetes and how we scale our clusters. So, we'll begin with the Flipkart's journey with Aerospike, how we started, how the problems have changed, how the management concepts have changed, how these things have evolved. And we'll also talk about how Kubernetes is used along with Aerospike. And it's not the Aerospike itself, it's also the ecosystem around Aerospike. We'll talk about those details. Okay. To briefly talk about the business use cases that are being solved, Aerospike is actually widespread in Flipkart. There are many teams who have adopted it already, and there are a variety of workloads, including caching, derived data store, and also many source of truth systems which are powered by Aerospike. And use cases also span many user path and non-user path applications like search and browse, product page, listings, and the user recommendations and the insights that's needed for the search ranking. All these information is actually powered by Aerospike as of now. So before talking about the current solution that is being used right now, so I'll briefly talk about the history. Flipkart is using Aerospike since 2015, and we have had 40 plus community edition deployments past then, and these deployments were mostly managed by the individual teams. So there were certain problems with this kind of a setup. So first of all, they were all on VM-based deployments. So with VM, as you guys already know, like getting the right size. So it's an on-prem setup. We have two on-prem data centers, and we also host it on one public cloud. So it's very difficult to get right size of VM cuts, and maintaining homogeneous VMs in a cluster becomes very difficult as and when the generation of hardware changes. And we also tend to waste cores and memory if the VM cuts are not correctly placed in a bare metal. And the hypervisor also takes certain hardware wastage. So we have we had certain automation playbooks in place to manage these VMs. But despite these automation playbooks, we still face a lot of operationally heavy tasks with VMs. And VMs also pose risks in terms of hot edits. And so the problems that I'm talking about is not particularly to Aerospike, but any database that we've been managing, like these problems were also present. So to address these concerns, as these databases are widely used in many microservices and many teams across Flipkart, we wanted to centralize this and solve it in a team. So we founded a team called DBaaS, basically a database as a service. And we introduced a few goals in this charter. So to talk about the charter, like there were multiple databases used fully decentralized, right, back then. So we wanted to promote tech standardization. We wanted to improve reusability. And there's also a certain learning curve these databases bring in. Like every time there's a new version release, certifying that, upgrading that, building those compatibility runbooks, there's a lot of challenge here. Like this is something also we want to solve it in the DBaaS team. And vulnerability management, solving for resiliency. And the idea was also to improve developer productivity. Like as an application developer, he should be only focused on building the client and integration with the database and not getting into the infra management, because that actually increases the learning curve. That's something which DBaaS would like to own. So simplified cluster management across data center sustainability. And we also go through a lot of preparation whenever there's a sale coming. There are a lot of degradation recipes, chaos testing, scaling of the clusters that we do. So this overhead is also something which DBaaS owns. And this DBaaS team also is a forum for any subject matter reviews and any expert reviews that is needed. This is the forum. So there are multiple tracks in DBaaS in Flipkart, and Aerospike track is something that started last year. And with Aerospike track coming into DBaaS, we also moved all these community edition deployments into enterprise license last year. And we were about 40 community edition deployments. Most of them have been connected to enterprise. And we also, as part of the tech standardization, we also looked at some non-Aerospike users, and we also got them converted to Aerospike Enterprise. So all these deployments are centrally managed by the DBaaS team, and we have seen significant improvement in the developer productivity. So if one were to build a DBaaS kind of a team in a company, so there are certain some more goals that we took in managing this. So there will always be new use cases, new cluster onboardings, ad hoc requests, manageability requests, hardware increments, always these requests will come in. And we don't want to spend any operational effort in managing this. So today we are at 170 clusters. Even if it becomes 500 or 1,000, we still want to scale using automation tools and using self-serve management tools, providing recommendation. So automation first approach is the key goal that we looked at. So with that said, this is something we debated, researched, discussed multiple times. We talked about, we actually compared how should the deployment strategy be. As I said, the number of clusters will continue to increase and we want to solve it with automation. So we evaluated VM-based solution, BM-based solution, and the best solution that's already out there was Kubernetes, and that was the way to go. So Kubernetes doesn't need any introduction. It promotes infrastructure as code. There is a lot of flexibility in deciding the pod shape. It's very quick and easy to scale the cluster, vertical scaling or horizontal scaling. And best practices are naturally enforced because of the infrastructure as a code. And the resiliency story is also built in Kubernetes. And it's very nice to see that the entire infra is literally written as code. You can program the infra by just code. So that actually gave us a lot of flexibility in managing these clusters. Okay, so this is an information-packed slide. So there are certain policies and guardrails that we put in this environment. So I'll just talk about them briefly. So first of all, we have a single Kubernetes cluster for the entire data center. We don't create separate Kubernetes clusters for each team. It's a single Kubernetes cluster, and it's also a multi-tenanted cluster. So what it means is a bare metal which is hosting an Aerospike container is not exclusive for Aerospike. Any workload can sit over there. It could be an application or it could be some other database. It could be anything. It's a multi-tenanted cluster. So there's something called multi-pod per host. It's a flag that is provided in the operator. That's something we enable. And pod IPs are also discoverable throughout the DC. We don't use any host networking for the inter-pod communication. And another optimization that we did here is, as I said, the virtualization adds some overhead. And also there's a performance penalty. So we set up this infra in such a way that the Kubernetes containers are deployed directly on the bare metal. So there is no virtualization here. So, and even with Kubernetes, we are getting the best possible performance, same as what we would get in a bare metal. And one more optimization that happened is Aerospike is something that we run as a non-root user. Thanks to the latest containerd release, we are able to bypass where we had to give root privileges or the root user access. We are able to run it as a non-root user. And we have also put in a lot of effort for optimal resource separation to avoid any noisy neighbor problems like the disk IOPS, PPS, network bandwidth. These things have gone in. And as I said, it's a multi-tenanted cluster. There needs to be certain guardrails put in where we also have clear separation of cluster scope objects and the namespace scope objects, to cluster scope being like the CRDs and the cluster role bindings, and the namespace scope would be something related to the operator like service accounts, role bindings, deployment objects. Okay, so to further improve the manageability of this cluster, we also divided the workloads into different namespaces. So there is a single operator which is deployed per data center, which takes care of all the Aerospike clusters, and operator has been able to scale very well with these number of clusters. So we also maintain different generation of hardwares, and we also select certain hardware depending on certain workloads. So for these cases, like we divided the workloads into management namespace, which only the management namespace holds operator and few DBaaS components, and the workload namespace is purely the Aerospike deployments. So to briefly talk about it, so the in-memory cluster has a different set of hardware, which is people who are just looking for demanding performance, right? Like tens of millions of QPS, like they usually go into the in-memory cluster. And people who are looking for high performance, but also strong durability. So those cases we put in the in-memory with NAS persistence, because NAS is the strongest durability solution that we have. And we also have a hybrid cluster with local SSD. This is something that we choose people who are looking for infra optimization and medium-sized workloads. And this is also extensible. If there are any new requirements coming in, we can change the workloads. So now moving on to the Aerospike Kubernetes operator itself. So there are a lot of cool features provided by the operator. I've linked the official documentation here. So I'll talk about a few more things that we really like about this operator. One is the seamless horizontal and vertical scaling of the cluster. So this is not the same as the way we do a kubectl rollout restart of a stateful set. It's not the same. Operator is very intelligent in these things. It's every time a pod gets restarted, it waits for the cluster to be stable. It waits for the migrations to complete. Then it moves on to the next pod. So if someone were to do it in a VM-based setup manually, waiting for migration to finish before they move to the next VM, operator does it magically with just a single command. And another cool feature which we extensively use in the operator is the vertical scaling of PVCs. So as you guys know, Kubernetes natively does not support modifying PVCs in a stateful set. However, operator has the intelligence to spin up a new stateful set, combine multiple stateful set as a single cluster, and give us a support for scaling PVCs. And this is also something that we use very often. And few other problems like write block size, which cannot be easily changed, can be changed with help of the operator. Configuration management, version management, they're all given. And with all this, since the time we went live in the Kubernetes infra, we have seen 100% availability with operator. There hasn't been any incident where we had a production issue because of the operator. It has been working very well for us. We also collaborated with the Aerospike engineering. There are a few suggestions that we had for our Kubernetes environment, and the team has been very responsive and very collaborative. All those changes have been incorporated. So one more optimization we did in terms of cluster discoveries. As a DBaaS team, we keep on running some migrations, in the sense like we change the hardware or we perform certain activity in the infra side where the pod IP can change, because that's the nature of Kubernetes. And we don't want to involve the customers, so we don't want to involve our clients to come online and change their discovery endpoint. To simplify this, we also create a TCP load balancer on top of Aerospike. And these coordinates are pretty much fixed from clients, the backup module, and the XDR. The way it works is the first touch point from the client to load balancer is only for discovery. It reveals the roster, and the following calls from the client to pods happen in a direct sticky manner without the load balancer. Okay, so briefly talk about the deployment lifecycle, right? So as I said, we want to program the infra completely. So our infrastructure is literally code. So if I were to create a new cluster, if I need to modify a new cluster, the SDLC process is like, there are certain Helm charts that we create for these clusters. So it goes through an SDLC process with proper code review. Someone approves the PR and it gets merged to the branch, to the master branch. And as and when it is merged, the CI/CD pipeline kicks in, which deploys the objects into the environment, and operator picks it up and it modifies the cluster. So literally, it's just code. We never touch the infra. It's all driven through code. Okay, so as I said, it's to make all this story happen, right? It's not just Aerospike that the DBaaS team is solving for. It's also the ecosystem. There are some more components that work around Aerospike to make this story happen. So Sandesh will be taking this forward.
Hey, thank you, Sharath. Very nicely put our journey so far. And I will be taking this story. Hello guys, I'm Sandesh, and I will be starting with the DBaaS ecosystem. So as Sharath already said that it's not just Aerospike or the Aerospike operator we deal with, right? So any production grade system to work in a robust manner, it needs multiple components stitched together and working seamlessly for providing a production grade quality of service, right? So I will just quickly brief what I will be covering, some of them in depth going forward. So we have like any system needs, we have health check which we have implemented, and the monitoring engine, which is going to come up in upcoming slides. It's going to be interesting segment. And we have implemented our own on-premise backup and restore automated process based on the criticality of system. We tune the frequency, we tune the recovery point objects, that how frequently we need to take a backup of a system, how in an automated manner, how the our tenants, as we are multi-tenanted system, we don't want to come in the path of tenants to do their recovery. So how they can do an automated recovery from their restore. Then we have built our own automated billing solution, which gives the tunability of generating on-demand bills for the license usage or the unique data usage that we have at this point of time. We run it daily basis, then we run it on weekly basis or monthly basis, and we also have this segregation in this multi-tenant system, that we know that what is the client which is actually heavily utilizing or creating some anomalies in the billing system. So this is the automated solution which is already in place. Then we have our own homegrown web portal for showing the configurations or the added feature that our tenants can need to perform in their cluster. We have also built some simplified hardware calculator to reduce our turnaround time for onboarding process. So we have 170 plus clusters as of now in our platform. And we need to do optimization as much as possible in our onboarding cycle. So these kind of simplified tools helps us a lot in that particular segment. So this is an overall view of our DBaaS architecture, where starting from the left-hand side, consider the small boxes as different data centers. It could be on-prem, it could be public cloud. We have hybrid cloud strategy in place. So these workloads which are on Kubernetes namespace works in tandem with a management namespace, which is coupled with these workloads, and we get all the telemetry data that we need from these namespaces. Starting with, we have our log store, which whatever logs that comes from any Aerospike cluster node, it gets published from this container to STD out, and it then automatically gets asynchronously replicated to our log store. The retention of data is very tunable, but because of we actually make it a point to only save data which actually makes sense, which is an information for us. So we filter it out. We just save the logs which are like errors or warning in these logs too. Then the metric component is kind of a collector which at real time collects the metrics which are emitted from all these nodes, and then ingest it into the monitoring engine. This monitoring engine, I will talk in detail later, but is primarily right now will be able to detect the breaches in the system and send alerts or the whatever warnings are there in the available notification channel to these tenants, and also the admins who are maintaining this multi-tenant platform that we have. We have operator that we have already taken up in the previous slides, backup solutions. Then there is an API server which acts as a gateway for all the incoming and outgoing requests from this DBaaS portal. So a tenant can actually have view on the configurations. They can edit some configurations which are tenant focused, which we don't want to learn or understand into their domain. So talking some more on the monitoring engine features, one of the heavily used feature is our reporting module here, which runs again at a tunable frequency, daily, weekly or monthly. Talking about this, a major problem in any hybrid or disk-based data store is the fragmentation problem. So we have ready-made insights whenever we want to recover or heal our system from the fragmentation problem. Like the top impacted clusters are always, we have the data and we have recipes in place that we can run, and all this fragmentation can be solved in a click of a button. Then as Flipkart is a business to consumers company, there are many times we have to do a lot of experimentation around parameters like A/B experimentation on an offer and everything, right? So there is an immense need of identifying the growth patterns on a particular system or a group of systems that were involved in that experiment. So this module actually covers the growth pattern insights, the utilization and whatnot that we want to analyze in a particular experiment that has been done. The traffic pattern, talking about the newly launched any product on our Flipkart website or flash sale which might come up, right? So we need to understand that what product, what brand actually has performed well or needs some more work based on the traffic insights that we generate. Hardware scaling insights, talking about our multi-DC topology that we provide to our tenants. Many times in the disaster recovery scenario, we need to actually provision our data based on the 2x growth. Let's say if there is a failover requirement on a DC catastrophic situation, right? So these kind of insights helps us to hardware scaling segment of our monitoring engine as well. The domain aware alerting threshold is something very interesting where we as a multi-tenant system makes point to not learn the threshold or the need of a particular system to tune their threshold. As a platform, we can tune at a constant or a static value of any of the breaches that we want, but there could be cases where, taking an example, a system which is okay to take a hit on their availability of rights, but they don't want any record to get evicted in their system. So for us to understand and maintain this logic in our system is very tricky. So we provide this lever to our tenants to have this tuning that, okay, you can tune your stop rights lesser than high watermark percentage. So these kind of levers we don't want to understand as a platform team, and we give this lever of domain awareness to our tenants. And then these clusters run like since we have our inception since last year. So over the 1 year period, we have seen a pattern a tenant has started using with. The pattern has changed a lot. New features got rolled out, but we don't have any awareness that what is the change that this feature brought into that system. What is the health metric that has gone down into that system? Let's say a tenant could be using a simple key value where, but then they started using CDTs altogether. This could create a lot of impact in their the memory, the way the memory gets allocated, the kind of updates they have changed in the system, right? So all the anti-pattern scanner that we have we have put down as a recipe to automated run, and any time we can have those results handy with us to work upon. Then this is our homegrown web portal to have visibility on the clusters for any tenants. Let's say a tenant has this Scorpius allied database present in multi-DC, right? So we give this visibility to our tenants, and also whether it's an in-memory cluster, it can be visualized by a simple logo. If it disk-based, if the persistence is present, we provide some sort of a visibility there. Then we have provided a visibility on the hardware allocated as well. As we are a DBaaS team, so with 170 odd clusters right now running, it's very hard to actually in a synchronized manner let our tenant know what is the hardware that we have allocated for you, because many tenants or in the critical systems, they need to have this awareness that what is the hardware. They have concern that whether we have under provisioned them or whether they are getting overbuilt on the hardware, we have over provisioned them. So this kind of visibility helps them to actually have trust on this kind of a DBaaS platform. Then we also display the configuration that we have set for them, and the capability for editing this config is there. Talking about future enhancement, I think we are getting a lot of interest requests from our internal users on cluster utilization, bus traffic, hardware scaling, kind of a forecasting mechanism that we can generate through this monitoring engine, and all the metrics and logs data that we have. We also want to build feedback loops for all the breaches that we are sending to our tenants, that whether this is a outlier, whether this is a right breach reached to you, we take that feedback into account and we learn it. And that's the process again we want to build in or bake in into our system, where we avoid sending those kind of breaches again to our system. Strong consistency and connectors is on our radar in coming quarter. Yeah. So as our DBaaS charter, going back to the previous slide, sustainability is again a very strong pillar for us. We make it a point to work on different Rs like data reduction by TTL tuning, archivals, and we have cleanup recipes, automation in process to identify the data which could be cleaned up, bring goodness to a system, tech standardization. So whatever components that we build, it is at a DBaaS standard. It is not like built in silos. One component for a one data store, another component, a duplicate component need to be built for another data store in a DBaaS journey, right? So we also try to prevent and detect early signs preventing any incidents. So that said, this is the story me and my colleague Sharath want to present to you guys. I hope you have the understanding of the content.
Thank you for the great presentation. In the first of the slide, first starting slide, you talked about the tech standardization. So can you tell us more, like with respect to Aerospike, what are the standardization that you have done or enforced across Flipkart?
Okay.
Like the version and any other settings or something that if you can share.
Right. So that was, tech standardization was more of a charter for the DBaaS. So tech standardization was charter of more of a DBaaS component, and DBaaS is not just limited to Aerospike, there are multiple databases. So that is where we wanted to standardize. As I said, we also identified few non-Aerospike user who could have used Aerospike, and that is the kind of reusability and standardization we are talking about. And the movement that happened, the community addition to enterprise movement that happened, we are using a uniform version. 6.1 is used in all the clusters right now.
Hello. Hey, hi Sharath. So I was there in Flipkart 2015, and we were using it for storing targeted offers. So user to offer, account to offer, and offer to account mapping. So I just wanted to know, I saw in slides now it's being used extensively for a whole lot of use cases, right? Sorry, not a whole lot of configurations, right? Like in memory, heavy in memory, and then heavy disk based also. So you guys would have done some kind of benchmarking with respect to other similar data stores available, Cassandra and Redis and others. So some numbers, since you are there for a long time, which you can share with us, or some story.
So, okay, this is actually very old information. It will take some time. Maybe we can meet outside to discuss this. But as you can see, Aerospike was clearly the winner.
Okay.
Last question, one more, last one.
Hello, my name is Ashutosh. Your session was mainly around architecture and the infrastructure. My main question was around like if you would like to throw some light on how data masking is performed and like how do you manage it like for the developers and all, so they don't get access to all the complete data. You get what I mean? Like, or should I elaborate?
So if you're talking about security aspects,
Security
yes, we do use encryption at rest for databases which use PII. Encryption at motion is something that is used at the app layer. We have not enabled it at the database layer as of now, and all the critical systems have ACL enabled. So these are certain measures that we have taken, and there are certain guidelines which InfoSec policy is also addressing, and the systems also go through certain rating. So this is something I take it very seriously, and it's managed very well.
So are there different clusters for like for testing purposes? There's a mass data and something like this, or?
So PII data is something which is off the grid. Developers don't have access to it. Yes, there is a concept of test accounts which is used for NFRs and testing purposes. Those SDLC changes are also in place.